I've got some more PCBs here from PCBway. Thank you very much PCBway for sponsoring the video and providing these PCBs to me at no cost. Make sure you go and check them out for their services because I've always been very happy with them. And I don't say that because I'm getting sponsored, I say that because I've used them myself before, actually buying the PCBs with my own money, and I've been happy with the service. Okay, now these are ordered over Christmas actually, and they arrived in basically less than a week from the time I ordered them. So considering the time of year, that's pretty impressive. What do we have here? So I've got two PCBs here. I've got another one which I've already made. I've done a video on this one already, making this one. I've done that as a separate board by itself. Now these two here combine to make one module. Now I'm actually thinking, I'm not sure I've got the headers I need for this. Now I've designed it. Basically these two boards will go together like this, and the headers, your header pins here, and I'll plug the two boards together. That's the plan. So this is the keyboard section here, and this is a controller section here. So the keyboard faces upwards, and all the electronics in the controller basically face downwards for access it inside the case. So that's the plan. You can see the headers here come together just there. So as long as I've got them right angle headers, I should be alright, but I'm trying to think where they are. I can't find them. Anyway, we'll get to that. So as I was saying, this keypad board here has got 9 buttons on it, and the idea is I get buttons like this, and hopefully they fit. I haven't tried yet, I guess we'll find out. I might have to wiggle it down into space because they've got tight positioning, but they do fit, so that's a good thing. So I've got to put 9 of these buttons like this on. Header, once I figure out where they are. And on the back of the board we have some surface mount resistors, little 100 ohm resistors we've got to put on these 0603s. This is just for the LEDs that are on these buttons. Well, I don't actually have to populate all of those resistors because I'm only actually using this one. That's the LED I'm using. They're all connected up, at least on this board, to this header. Every connection's got a connection to the header. But on the controller board here, I'm only connecting the pins which are used because I've basically run out of inputs on the ESP32. I haven't used them. I think I've got about 2 inputs spare or something, I think, or 2 GPIOs spare. So most of these pins actually don't have a connection. There's only, I think that one, is it? It might be the only one, which is an LED. So I've only got one LED wired up out of this whole panel, but I've provisioned for it on this one. So if I ever change what I'm doing with this controller board, I may be able to connect all the other LEDs up. I wasn't really too worried about it. I mean, none of these really need to function. That's the only one which I really had a plan for functioning, is that one there. And that's button number 7. So I've actually got a strange numbering scheme on this panel. I'll go 1, 2, 3, 4, 5, 6, 7, 10 and 11. I've got it numbered back here, so I kept the numbering of the parts that match as well. So that's 7, 10 and 11. 8 and 9 are 2 different buttons on a different row. So you also see I've got some pads here and here. These are for connection to rows and columns. Right, so this is a matrix keypad. I did actually start out having individual inputs to the microcontroller. Then as I started getting a bit low on inputs, I realised actually no, it's not going to work. So I changed to a matrix pattern instead. So you've got columns, so there's 3 connections and 3 rows. Well, I've actually got 4 rows. There's 1 row which isn't on this board. So instead of using 12 inputs from 12 buttons, you end up using 7. 3 for columns, 4 for rows. So it's much more efficient. So I'm saving 5 inputs. There are other ways of doing it as well, but this is just the way I mean, you can actually, some I've done in the past is using analog inputs. So I'd actually use a resistor network on the buttons. I haven't done it in this case, but I've done it in the past where I could have 4 buttons running on a single input using analog input, and all I was actually doing is measuring the voltage on that pin, and based on the voltage I decide which button should be pressed. I've done it before. It's quite a good way of doing it. If you really push for inputs, you can do that sometimes anyway, but that's not what I've done in this case. Okay, so which one should we make? I think we'll make this one first. Put this one together. So I'm only going to put on that one surface mount resistor. I'm not going to do all of them because they're not going to be used at this stage anyway. I may even use like expander, input-output expander. You can, you know, get those ICs, you know, GPIO expanders, so you can run through SPI or I2C or something like that, and then you can actually add on to them. In fact, I've got a module over here somewhere. Where is it? This thing here is a USB host module, but you can see it's got loads of holes. That's because it's got inputs and outputs as well. So it runs off SPI, but it's also an input and output expander, so it's got GPIOs on this chip. So SPI will run to it, control it, and then you can turn the inputs on and off, as well as being a USB host. I haven't actually tried it yet. I've had other things to do, but this might be a good solution if you're, you know, getting a bit short of inputs and outputs, and maybe you need a USB host board. This can maybe do it for you. Fairly cheap too. I might chuck a link down below for these. Something. Be waffling enough. Let's get these made. So I need some 100 ohm resistor, so we'll chuck that on. This doesn't have any capacitors on this board, but the microcontroller board, the interface board here, does have a various range of capacitors on there, quite a few. So we'll worry about that when we get to it. We just need one for now. So this is one of these little Chinese sample books, which are really handy if you just want to have a wide selection of values. I recommend getting one. Go to AliExpress and get them off there, or Banggood maybe, I don't know. Resistor 0603, I've got a wide range, I've got a whole bunch of different books. Loads of different sizes, different types, you know, resistors, capacitors, that sort of stuff. So I always recommend when you're making PCBs, you put on the surface mount parts first. So I'm just using a little cheap flux pen, just that one there, just like that. Now I've got soldering iron. I'm going to use this solder here, which is SN62. It's like a lead tin and silver solder. It's quite a high quality one. And what I'm going to do, try and get so you can see what I'm doing as well, hopefully. Maybe. Just going to put a bit of solder on these pads, well, one of the pads. And then we'll put the resistor in place. It's going to be a little awkward. I need to turn sideways. It might be in the way. We'll see. We go. Just like that. Okay, so resistors in place. Then you put solder on the other side. Yeah, try and get it so you can see. And back to the first side again, just to even it up. Here we go. That's that on there. So what we've got to do now that's on place, is I'm going to put all the switches on. I've got to find this header. I'm sure I've got some somewhere. Sure I have. I think I can find them. Anyway, let's put the switches on. So I need to put on grey switches in these positions. There's a grey one there. These are all quite tight fitting, so I need to get all those lined up and push them through nicely. But it's actually really nice to find a proper footprint for these switches. Sometimes you don't get that lucky. I was actually quite surprised. So we've got a green switch in the middle here. I think I might put some solder across here. I'll just put a little bit of solder across that bloody hole here. That's going to be a pain. I'm just going to try and push that through at the same time, so that's okay. Now I want a yellow, a black and a red. So black's going to go in here. In fact, I'll stop recording. I'll get all this set up. You got the idea, and I'll come back once I've got it all done. Okay, that's the buttons fed. I'm pretty sure this is the colour pattern I actually want. So these are correction buttons, I suppose. So these are adding faults. These are for correcting the faults. That's for clearing, that's submitting, and that's for bringing up a menu. So I think it's kind of what I want. I want that one to be definitely quite bright. Now these colours, it's actually not that big a deal because you can actually pop these tops off. You can lift those off and take them out. So if I need to change colours, I actually can just lift one off and pop a different one on. You can do that. It's not a big deal. Let's get on to building this thing. Now they're all pretty much, I think they're all pretty much straight now. They're all pushed down, flat. Just trying to get a good view. I'm pretty sure they're all down properly. They look like they are. Yeah, they all look pretty much even. I think they're all there. So we can solder these down. This is what I should have done before I put the switches on, put some flux on. Never mind, we'll just do it now. It's still going to flow. I mean, there's flux in the solder anyway. I would prefer to actually have it a bit nicer. There's not much come out of there, is there? I might use different flux, we'll see. Right, we'll see we go. Let's give it a try. Now I'm going to use my silver solder again. It's pretty expensive, but I want this to last. I want it to be bulletproof. It needs to be 100% reliable, so I can't have any fatigue joints or any kind of things like that. It just won't be acceptable, anything like that, you know. No good. Let's start soldering. Alright. It's all pretty good. Actually, I should get my extractor going, shouldn't I? I shall come back and get my extractor going. Hold on. So unfortunately having an extractor going is a bit noisier, but it gets rid of the fumes. It's necessary evil, really. You can't really be breathing this stuff in, it's not good for you. Just those ones. I think there's enough on there. So I'm going to do them again, and you can't see what I'm doing. Of course you can't. Problem being right-handed, I've got the camera on the right hand side. Of course. Let's try and do this. Is this going to work? Yeah, it'll work, okay. Good. Alright, next one. Beautiful. Easy as that. So I was going to do the whole lot like that, and then I'll come back. Do one more, then I'll stop the camera. Don't have to see me solder if it's going to run up to you. I think you get the idea. This extractor I'm using here, I actually did a video on building this little DIY fume extractor. So go and check that out too. I'll be in my videos, it'll be there somewhere. I think I called it DIY fume extractor. So it's just an extractor fan, and I made a 3D printed housing up at the other end of some ducting, which has got filters on it. So it's all cheap, make it yourself, easy to get parts. It's well worth doing. It's better than paying hundreds and hundreds of dollars for an extractor. At least then you got something which is getting the fumes away from you and helping filter it. Okay, that's the button soldered on. Right, now I need to find some header for this thing. Okay, so I found some male header. Annoyingly I can't find any female header. I might have to get some, looks like. So that will just sit in there like this, as you can see here. So it should be right basically on the edge of the board. It pretty much is, it's pretty close. So I should be able to get a comparable female header for the other side. We should end up against it for this board when I go to make this one. That's the plan. I hope I got it right. Anyway, let's solder these on. So it's got to be soldered on from this side. So it's going to be a little bit tricky. Let's get some flux on. Okay, so what I'll do is I'll solder one pin and then check the alignment, make sure it's straight, because it would have to be straight, otherwise it might give you some problems. Come on, solder. So the terminal could probably use a bit of help. Might put some flux on the terminal rather than just the PCB. That is straight. Ish. What do you reckon? You think it's straight? I think it is. Solder some more pins. Just stick some more flux on this, because these pins seem to need it. Just do one more, make sure it hasn't moved whilst I was doing all that. That's better, I've got the flux on there. Yeah, it's still fine. Now I can't see what I'm doing. I'm trying to look at the camera. Yeah, it's not going so well. Turn it around. Maybe do it from the other side, might be a bit easier. You know, you get the idea. I don't record the whole thing, do I? Okay, so that's soldered on. I've got to get some IPR in there, give it a clean up, and then that's basically that board there done. Now, do the ones on the back of the board. Alright, a bit more of that and we're done. So that's that board there completed. That's that one finished. Now let's move on to the next board. So on this board here, we're going to do all the surface mount parts again first, because it's just easier to do before we get the other stuff on there. So we've got some 100 nanofarad caps. Probably I might change one of the values over here, just in parallel, just to give it a range function. This helps to get different frequencies. I've also got a couple of little surface mount transistors to put on there, and a few resistors. Pretty straightforward really. So I'm going to start putting some flux on again, just like I did before. Flux pens are really handy. Just gives you a bit of a helping hand. It's not 100%, but it helps a little bit. And I'm going to solder one pad of each. I mean, again, I could use hot air for this, but I'm not going to. Get my straight going. Get some parts out. This is a 68 nanofarad. So I'm going to put 68 and a 100 side by side just over here. And stick on that one there. Doesn't matter which one it goes on. Are you ready? Side on. So I'm done. Now we've got all the 100s to do. So I've got 5 of these out, and we'll just put them in place like I did the other one. Put them tipped over here. One more, where's that go? Up top here. Oh, almost lost it. Of course, the last one's going to be the hardest one to get right, isn't it? Right. Because it's got a ground plane that side, so it's a bit hard to get on. Sugging will heat away. Probably use more flux on this actually. Let's do it again. Okay, so that's the capacitors down. I think that's all of them. Don't think I've missed anything. Well, now I've got a couple of 10k resistors to put down. And I've got the things out of the packet and the whole strip fell apart, so I've got quite a few of them now. I'll have to get some more strips. Okay, so this one's done. Right, that's all the resistors mounted on there, so that's that done. Now I just need to get the transistors on. I've got my Vauxhall kit here, so 3904 is what I've planned to use. A bunch of these. Got tweezers, just need 2 of these. Easy as that. Right, so let's get this one on. Already some solid wonder pads. Make sure it's down properly. I think that's pretty much okay. Next one, which goes down here. Try and get it straight, shall I? Wonky. Fortunately, the pad I've chosen to do is the ground pad, isn't it? So it's sucking all the heat out. Okay. that one. Oh, that was a bit wonky too. No, too late. Soldered now. Done. So it's on there. That's all the service manual parts on there. So I've just managed to get this connector here on there. The footprint isn't exactly the same as the connector I've got, fortunately. It's the same footprint, but it looks like it's out very slightly on that pin there. You can see it's slightly wonky forcing it in there, so not ideal. And I'm looking at this footprint as well for the capacitor, and it's kind of in the way. So I was unsure about that. After a while, if it's too bad, I'll stick it on the back of the board. You know, it's not a big deal. I could also put it over here, because I'm not going to be using this big header here, the 7-pin header. I'm not going to be using that, so I'll probably just move the capacitor over here. Not a big deal. Okay, it's coming along. I've got most of the headers on there now. I'm not going to record the whole process. I'll just show you at the end of it, to be a bit easier. So there we go, that's where we're at now. I've got the capacitors on there, got the headers on. Now there's a few things I don't have yet. So I don't have this female header I need for this yet, so I'm going to have to do that later on. And the sounder, or buzzer we want to call it here. So I've got two footprints for a 7.6mm or 6.5mm. I think I've ordered a 6.5mm, so it can accept either size. So once that turns up, I can put it on there. I've also got to do the SD card. I've got to figure out how I'm going to mount that. Because of the issue with this connector here, which I was worried about, but not overly so, I thought it might be a problem, is that capacitor there. I've moved it to over here, so it's actually put it into this header position here, which I'm not even using. Doesn't really matter. And also left off the double pin header here, that 3.3 volt ground header. That is only there in case I needed it. I've already got this double one here anyway. You know, it doesn't really matter too much. I left it off too, so I can get the connector in easy enough. It's a bit of a shame, but it's the way it goes. The other problem I've got is that this footprint here, as I discovered when I did the other board, I got this footprint off the internet. It is for this module. It's basically for it. It's got the same part number on it. It doesn't fit. So when I went to go and do the other board, I found the same problem. The footprint doesn't match the board. It's like it's been scaled by, I don't know, 5 or 10%, something like that. So the board is both slightly wider and slightly longer than the footprint. Otherwise, the footprint is exactly right. It's just the wrong dimensions. So I don't know what's happened there. So unfortunately I can't just put that board straight on there, which is what my intention originally was. So I can probably still make it work. I can probably just stand it off a little bit, just use longer wires and hook it in slightly off at each end, bend them in. Some quite stiff wires to mount it, and that'll sit there just fine. Not too worried about that really. It doesn't even have to be on here really. I could always just put it remotely and just run a couple of wires in. It's not a big deal. I may not even use this module. I might use a different module. I've ordered some more. Maybe the ones I've just ordered will be smaller. I really don't know. So we'll find out. So yeah, SD card's got to go on the back here. I've got to probably put on, I might put a female header there, I'm not quite sure. I've also got a female header this side for the display, because it sits that way around, like that. And displays will sit over here and get it in shot. Right, so the display will sit in that section there. So that's also the back of the board, and that's the top in the case. So this will be on standoffs as well. And the SD card will sit here, coming off this side. So I'll put a hole inside the casing for the SD card. Yeah, that's alright, it's almost there. So that's the LoRa module, that's the FTDI connector, so that allows me to program the LoRa module in place. All I've got to do is change these jumper settings on here. So one side is in program position and the other side is normal position. And then I can just plug an FTDI connector in there and program it without too much hassle at all. It disconnects it from the serial connection from the ESP32 as well. Yeah, I can't do a lot more until I get the rest of these parts, which is a bit annoying, because this is something I want to get finished. What can you do? So I've got my 3D printer running now for about 8 hours. Printed this, so it's taken a while. I probably could have optimised it. I had to use a different slicer software because my normal one for some reason wouldn't work. So the settings weren't optimised in it, so I could have done it probably in half the time. It was originally going to be one day, so I already got down a bit. So this is a cover for this piece. Hopefully I got the measurements right. Look at that. It fits it perfectly. Now let's get this thing off here. Now unfortunately, because it's face down, the surface appearance isn't going to be wonderful on it. So I'll need a bit of a clean up to make that look nicer. But there we go. That's how it fits. Just like that. Awesome. Just needs a bit of cleaning up.